Assalamu alaikum and hi everyone. My name is Dina Farhana Binti Amri and I'm from class MT2. Today I'll be presenting about heuristic construction, which is the code MTES1142, the computational thinking in mathematics. Introduction. According to Neural Networks in 2003, a construction heuristic in computer science refers to an approach that involves finding an initial solution, such as a single tour of cities, using a specific method, followed by attempts to enhance this solution through local search techniques. The objective of this slide is to construct heuristic mathematical problems at three levels, which is easy, intermediate, and advanced. The next one, we apply computational thinking to solve non-routine problems. And the last objective is we demonstrate real-world applications of heuristic problem solving. So, there are four core computational thinking skills. First, we have decomposition, is to breaking down the problems. Next one, we have pattern recognition. We find the similarities. The third one, we have algorithmic thinking. We create step-by-step solutions. And the last one is abstraction. We focus on what's important and ignore the irrelevant information. Just I said just now, we have three levels of problems. We have easy level. It is a foundation of problem solving using basic computational thinking. Then we have intermediate level. It requires deeper reasoning and multi-step solutions. And the advanced level, which is the hardest one, it involves complex problem solving and real-world applications. So, level easy, it is about a grouping cows.
Park sat quietly on his porch, a cup of steaming tea in his hands. His eyes wandered over the cows, admiring the way they moved as a herd, tails flicking and heads bobbing as they chewed on fresh grass.
These cows are always together.
He mused aloud, his voice soft and thoughtful, mingling with the distant chirping of crickets. Pak Ahmad leaned forward, elbows on his knees, and let his mind wander through possibilities.
What if I divided them into equal groups for the chores around the farm? Each group should have at least 2 cows, and I don't want any cow left out.
He pondered, drumming his fingers against the side of his teacup. The cows clustered together, as if awaiting his next move. Inside, the farmhouse smells of old wood and earth. Pak Ahmad clears a space on his worn table, flipping open his notebook and uncapping a pen. He scribbles numbers, draws circles, and murmurs softly, the occasional sound of his calculations drifting through the open window to the curious cows outside. Pak Ahmad taps his pen against the notebook, eyes darting between scribbled groupings.
2 groups of 5? 5 groups of 2? Are there other ways?
He wondered aloud, frustration and excitement mingling in his voice. Each possibility is carefully weighed. He wants fairness for every cow. One cow nudges another, as if questioning what Pak Ahmad is plotting. The air is alive with anticipation, and the gentle night sounds add a sense of mystery to the task at hand. Shadows lengthen across the field, and a hush settles over the farm. Pak Ahmad takes a deep breath, feeling the weight of the challenge.
Tomorrow, I'll tell the cows about their new teams. But first, I must be sure I've found every fair way to group them.
He promises himself. The cows, ever loyal, wait patiently for the morning and the answer to their farmer's clever puzzle.
So, from that video, we notice a problem that a farmer has 10 cows and he wants to divide them into equal groups with at least 2 cows in each group. So, how many different ways can the cows be grouped?
Okay, next we will use solution 1, which is drawing a diagram. So step 1, we draw a set of 10 cows. Step 2, we divide the cows into different groups. The groups can be shown as circles or separate sections. So in this slide, we have one group of 10 cows. Next, we have two group of 5 cows. And the last one, we have 5 group of 2 cows. For solution 2, we use a table to solve the problem. For your information, a table can help organize the possibilities and make the solution more clear. So, for the first column, we have number of groups. The second column have number of cows per group, and the third column have total number of cows. So, from this table, there are three possible ways to divide the cows. Solution 3, which is simplification. Step 1, we list the divisors of 10, which is 1, 2, 5, and 10. Step 2, we eliminate the divisor 1 because we need at least 2 cows per group, so we exclude the number 1. Step 3, we check the remaining divisors. So 2 cows per group, 10 over 2, which is 5 groups. 5 cows per group, 10 over 5, we have 2 groups, and 10 cows per group, 10 over 10 equals to 1 group. So step 4, we make a conclusion based on that calculation. So the valid groupings are, the first one is one group of 10 cows, the second groupings which have two groups of 5 cows, and the third one we have 5 group of 2 cows.
We will move on to level intermediate, which is about water tank filling rate.
Zara, a curious girl with bright eyes and tangled hair, tiptoes into her grandmother's shed. She pauses, captivated by a peculiar contraption in the corner. A bulky water tank with a brass dial gleaming on its side.
I've never seen anything like this before.
She murmurs, reaching out to brush away a layer of dust. Zara squints at the label, reading aloud the words.
This tank fills at a special rate, liters per hour, depending on the time taken out.
Her brow furrows in thought, and excitement flickers in her voice as she continues.
So it doesn't fill at the same speed every hour. It changes.
She carefully turns the dial, setting the timer for 4 hours, her heart thumping with anticipation. Zara settles onto a rickety stool, notebook in hand, eyes wide with wonder. She watches as the water level creeps higher, noticing that the flow ebbs and swells ever so slightly as time passes.
Is it possible to figure out exactly how much water will be in the tank after 4 hours?
She muses, jotting down observations, determined to unravel the puzzle. Zara flips through her notebook, sketching graphs and scribbling numbers, her brow furrowed in concentration.
If only I could see how the rate changes every hour.
She whispers. She imagines the tank as a living puzzle, each drop of water a clue, each hour a new twist in the mystery. Zara squares her shoulders, her eyes alight with discovery.
I won't give up until I solve you.
She tells the tank, her voice brimming with resolve. She sketches one last equation, feeling the thrill of a challenge well met. Zara glances back at the tank before closing the shed door.
Tomorrow, I'll find the answer.
She vows, her mind swirling with ideas. In the fading light, the old tank seems to shimmer. No longer just a machine, but a magical puzzle waiting for the next day's adventure.
So, from that video, there's a problem. A water tank is being filled at a rate of 5t squared plus 20t plus 30 liters per hour. where T represents time in hours. Find the total amount of water collected after 4 hours.
To solve this problem, the solution one, we use a mathematical sentence. We are given a rate function rt equals to 5t squared plus 20t plus 30, and we are asked to find the total amount of water. In mathematics, when we want to find the total from a rate, we integrate the rate function over the given time interval. So step 1, of course we need to write the mathematical sentence. So total water integral 4 integral between 0 and 4, we include the rate function equal and dt. So the next solution is simplify. So step 1, we split the integral into integral between 0 and 4, 5t squared dt plus integral 0 to 4, 20t dt plus integral 0 to 4, 30 dt. Then step 2 is we solve each part. So uh, for integral between 0 and 4, 5t squared dt, which is a, we got 320 over 3. Meanwhile, for b, which is integral between 0 and 4, 20t dt, we have the answer 160. Meanwhile, for the last one, c, we have integral 0 between 0 and 4, which is 30 dt. The answer would be 120. So solution 2, which we need to simplify them. So step 3, we add all the parts. So total water, which is equal to 320 over 3 plus 160 plus 120, we will get 1160 over 3, which equals approximation of 386 0.67 liters. That's the amount of water after 4 hours. We also can use another solution to solve this problem, which is we use work backwards solution. So step 1, what is the final goal? We want the total amount of water after 4 hours. Step 2, what do we have? We have a function rate that gives the rate of water per hour. So step 3, what connects rate to total? It is integration. To go from rate per hour to total liters, we need the area under the curve of the rate function between 0 and 4. And step 4, which is the last step, we apply the idea. So we integrate total water integral 0 between 4 r t dt equals to integral 0 4 5t squared plus 20t plus 30 dt. Then we solve it like a normal calculation would.
Okay, we'll move on to level advanced. That's about satellite and hyperbolic orbits.
Alia, a young scientist with keen eyes and a restless mind, stands beside a glowing console. Data streams across the screen, tracing an intricate curve. Stellar One's hyperbolic orbit. Around her, engineers murmur, their faces lit with anticipation and the faint blue of digital readouts. Alia studies the numbers, her brow furrowed.
We need to send a data burst to Stellar One,
She announces, her voice slicing through the room's low hum.
but to make sure the signal is strong and fast, we should wait until it's closest to us.
Alia speaks, her excitement building.
It's not moving randomly. It follows this equation. If I can find the shortest distance from that curve to our station at 6:0, I'll know the perfect time to send the signal.
Her team
teammates, inspired by her determination, gather around, their curiosity piqued. Alia mutters calculations under her breath, her eyes darting between the math and the live feed of Stellar One's path.
Just a bit more. If I solve for the point where the distance is minimal, that's when we'll act.
She whispers, her determination unwavering.
There. That's the spot. Stellar One will be closest to us right here.
She declares. Her colleagues nod, quickly inputting the coordinates and preparing the data burst. The sense of collective focus fills the room, every eye fixed on the screens. A cheer erupts among the engineers as confirmation flashes on the screen. Stellar One has received the message, clear and strong. Alia leans back, relief and pride mingling on her face, knowing her love for mathematics and orbits has brought the mission to success just in time.
So, from the video, a satellite follows a hyperbolic orbit given by x squared minus 4y squared equals to 16. A ground station is located at 60 coordinate. We need to find the closest distance between the satellite and the ground station.
So, to solve this problem, one solution is that we draw a diagram. So, step one, we sketch the situation. We notice that hyperbola is the equation is x squared minus 4y squared equals to 16. And this hyperbola it opens left and right, and it's centered at the origin 0, 0. So the ground station it will be at the point of 60, and the satellite is at some point which is the unknown point. We assume that as x, y coordinate on the hyperbola. And there we go. We sketch the situation using GeoGebra, or we could use it some graph to sketch them. Another solution, we can use some mathematical sentence. So step 1, we write the distance formula, which is d equals to power root of 2 in bracket x minus 6 square plus y square. To make our calculation easier, we square all of them into d square equals to in bracket x minus 6 square plus y square. So this we concluded as equation 1. We need to multiply by square root because we need to get rid of that square root of 2. So step 2, we use the hyperbola equation to eliminate one variable. So the hyperbola equation, it will be x squared minus 4y squared equals to 16. We want the y squared to be our subject. So it will be y squared equals to x squared minus 16 over 4. And then it will be our second equation. So solution 3, which is simplify. So step 3, we substitute the equation 2 into equation 1. And there we have d squared equals to in bracket x minus 6 square plus 6 square minus 16 over 4. And then step 4, we expand and simplify them. And then for x minus 6 in bracket square, we need to expand them. Then we get x squared minus 12x plus 13. And then to solve the problem, we need to make the denomination the same. So the last answer, it would be 5x squared minus 48x plus 128 over 4. And then we let it f in bracket x. So step 5, we differentiate to minimize. So we differentiate it, then we got 1 over 4 in bracket 10x minus 48. Then we equals them into 0 and then we get x equals to 4.8. And step 6, we find the corresponding y. So y squared equals to 4.8 squared minus 16 over 4, and then we get 7.04 over 4, and then the answer it will be 1.76. And then the approximation value of y it will be minus plus 1.33. Then step 7, we calculate the shortest distance. The value we got earlier, we can put it into the distance formula. So we have d equals to square root in bracket 4.8 minus 6 square plus 1.33 square. And then we got the answer square root 3.21, and the value of the answer it will be 1.79. And there we go, the final answer it will be 1.79 units to show the shortest distance between the ground station and the satellite.
10. Application in real world context. In easy level, grouping is used in logistics, warehouse operations, and even in sports teams. Meanwhile, in intermediate level, integration models water flow in civil engineering and agriculture. And for the advanced level, hyperbolic orbits are essential in aerospace for satellite trajectories and GPS systems.
So, conclusion. Mathematics enhances problem solving through heuristic and computational thinking. Logical grouping aids logistic, integration applies in fluid mechanics, and hyperbolic orbits guide satellites. These examples show how computational thinking skills and heuristic help solve global issues through structured reasoning and pattern recognition. So, our big idea of the course, which is mathematics as a universal language for empowering teachers with computational thinking skills, and have some essential questions to relate with this big idea. So, the first question it will be, how does computational thinking skills and heuristic able to produce a superior teacher? So, to answer this question, we embedding these skills into teaching practices empowers educators to become superior facilitators of learning, which teachers who can guide their students in navigating complex problems. So, second question, how does computational thinking skills and heuristic drive educational change? So, this fosters educational change by encouraging innovative analytical approaches in the classroom. And the third question, how does today's education produce the inventor generation? So, for this question, the answer as a result, today's education nurtures the inventor generation, which is some learners who are not only consumers of knowledge but also creators of solutions. And so it covers 3 out of 4 essential questions that I answered. So, from all of this, we can conclude mathematics serves as a universal language that equips educators and learners alike with the tools to think critically, solve problems creatively, and drive progress across their disciplines. So, this is the references that I refer to. Some of them I refer to websites, and some of them I refer to some book. So that's all my presentation. So thank you for paying attention. Thank you.